Well, hello, and welcome to our lesson on diodes. I hope you've had a lovely weekend. Today is actually a very short video. If you look at the side of the screen, you can see there's only 3 slides I'm going to be talking through, so that's nice and easy. So if you can please pause the video, make appropriate notes, etc., and then I shall see you on Zoom to do some questions. Okay, so diodes, not 15th of Jan, so write today's date, and let's crack on. So what is a diode? A diode is an electronic component that only allows current to flow in one direction. They are made up of 2 layers of different materials that have either excess electrons or excess holes. Now, you'll see that I've put holes there in inverted commas. That is because it is a massive oversimplification in terms of the actual physics behind it. Basically, some materials have many free electrons that aren't really bonded to anything. And some materials are desperately craving electrons. I know I'm anthropomorphizing here, so they don't actually have any feelings, but you know what I mean. So that's what I mean by holes. There's spaces for those electrons to fill. It is very easy for an electron to go in there and So if you have a little look on the right-hand side, at the top you will see the circuit symbol for a diode. Now it contains an arrow and a line. Current can flow in the direction of the arrow. If current tries to flow in the opposite direction, it has a massive resistance. And that is because you're trying to get electrons to leave a material, and again, picture the fact I'm doing inverted commas here, leave a material with holes to go into a material with lots of extra electrons. It just doesn't work. So at the bottom there, you'll see 2 circuits. One is where the diode is in what we call the correct polarity, and that just means it's in the right way round. So current is flowing from positive to negative, so it's going counterclockwise, and yes, it can go through the diode. Fantastic. Now that specifically is a light emitting diode, which we'll go on to on the next screen. On the right hand side, you'll see that they've reversed the polarity of the diode, and so current cannot flow. And so the LED is not lit up. So let's go on to that LED. LED stands for light emitting diode, and it's made of material that emits light when it conducts electricity. They are very energy efficient, so are often used as an indicator that a circuit is on. So think about those standby lights on your TV or whatever. There tend to be LEDs, and you'll know that most Christmas lights now, the new ones, are LEDs as well. Okay, so a current voltage graph for a diode. On the right-hand side, you'll see the graph. On the left-hand side, you'll see the main conclusions from said graph. First bit, current and voltage are not proportional. So you will notice, really, none of that is a straight line. It is a non-ohmic component. Just a reminder, Ohm's law is when current and voltage are proportional to each other with a constant temperature. The resistance, i.e. the inverse gradient, is not constant. We can tell that because the slope of the line changes. Polarity does matter. And by that I mean you'll notice there is no current flowing on the negative side of the graph because, as we know, it doesn't let any current flow. So let's look at the graph, and you'll see I've labelled various key points. A, on the left-hand side. This is reverse polarity. The diode is pointing the wrong way. There's extremely high resistance. On the right-hand side, where you've got the current flowing pointed the right way, B is the first bit of potential difference where current is actually able to flow. And we call this threshold potential difference. And from this point onwards, resistance drops quickly. So that allows current to flow. So you'll notice that basically you don't turn the diode round and at 0 volts current starts flowing. You've got to get a bit of voltage in there first. C is where current is flowing, resistance is very low. You've got, a normal circuit going on. All right, so please come join me on Zoom, and we're going to look at the summary questions on page 148. Thanks, everyone.